Hello friends, welcome back to the bench. Our patient today is B365 Phantom Motherboard. Gaming motherboard, basically. It's a very nice one for a few reasons. Well, first of all, we have standard 4 DDR4 slots, two M.2 NVMe drives, M.2 Wi-Fi, and obviously two full size. Are they full size? No, not one full size PCI Express, and yeah, this is not full size, but full size slot. So technically, you can connect two relatively powerful GPUs to it. And what makes this one interesting is actually the fact that the Vcore voltages, or what you normally expect to be Vcore, the Vcore is delivered by these 6 coils, and normally all these coils are connected because it's pretty much the same voltage, but this one separates GT and IO, right? So these are separate. Usually on the boards these are all connected and everything's connected to the CPU. There's also nice separation over here from our 5 volts coming from the power supply. We separate into USB voltage and 5 volts dual, which in turn supplies through these 4 transistors, and these 2 coils connected in parallel supplies our memory voltage, which also supplies the CPU, at least some pins over here. So we have 4 different voltages created separately going to the CPU, essentially. So that makes it a little more interesting. Also, the interesting part is that we don't seem to have an EC chip on this one. The SIO, which is this one, controls, or it turns on the power supply, which normally is done by the EC. Instead of EC, we have an MCU over here, which does talk to the SIO, or at least it has a reset pin. But it does talk on I2C, which is this one. And I'm not sure. This is clock. This is data. It looks like LED. This is SM bus, which talks to the TPM. Interesting. Well, the interesting part is that we only have SIO and nothing really more than that. So let's give it a quick visual. And the CPU socket is not damaged. I don't see any pin bending or any broken pins, nothing like that. So usually when the board like this is sold as 4 parts or not working, that most likely is faulty SIO, or in more rare occurrences, it's some simple fault of the power, and usually it's somewhere on the Vcore. So also what we have is, or are LEDs, CPU, RAM and VGA, and boot. So if we see the boot LED light up, that means we went past the self-test and the BIOS will start being loaded. So if we get that far, that means we have a BIOS issue on this one. And BIOS issues actually are pretty common, because you can corrupt your BIOS just by connecting a faulty GPU to the board or some other faulty peripherals, usually on PCI Express, as they can update. By update, I mean they can write to the BIOS. They work with the BIOS. So the external device has its own BIOS, and it might need to copy over some data to the writable memory region of the BIOS, and that can cause corruption if there are any faults. Now these two coils seem to be replaced because they're not facing correctly, or it came from the factory like this. Who knows? There's a little bit of flux over here, it seems like. So perhaps this capacitor has been removed. Very interesting. And there is no sign of liquid damage except this one little spot over here. I'm not sure what it is, but it looks like liquid damage. So this might be the reason why this board is here. And now, other than that, this is our linear regulator. Let me get something to point with. Maybe this. So this is our linear regulator. So this is the first thing we need to check to make sure that the SIO is indeed supplied with energy, so it can turn on the board. Okay, so the procedure is the same. First we connect the main power rail without the Vcore. If it boots and the diodes are lighting up, that means SIO is working. No EC, so at least we don't have to worry about that. So if the SIO is working, the board should boot and should light up. But for that we need some CPU. Let's get this one. And this is i3 6th generation. I use these because they are like $10 on eBay. So if I fry it during testing, that's fine. I mean, it's not fine, but at least instead of losing 60 or 70 bucks for some i5 or i7, I'm just 10 bucks out. So no big deal. And so, is it bent? Yeah, it is slightly bent. So there might be just soldering issues on this one. We'll see. So let's put this in. Now, why do I always test it this way without putting in the Vcore? Is basically experience. Usually when you connect Vcore, or usually the issues are on the Vcore. That's where we draw the most power, because GPU would be the component that needs the most power, you would think, and probably is, but we connect externally to it, so it's not the board that controls that voltage, it just gets that voltage directly from the power supply. Same way, Vcore is provided, and a lot of power needs to be supplied to the CPU, and that power varies because it depends on how much load is on the CPU. If you're playing a game or using some 3D modeling software, something like that, there's a lot of computations that go with that. So GPU is loaded, but CPU will also need to be throttled up. So that makes a pretty good procedure to eliminate that. At least you know if it boots like this and you connect Vcore and it doesn't boot, then you know the problem is in Vcore somewhere. Some kind of problem. Let's get a nice view over here so we can see the power supply. CPU is in, and now let's flip it on. It flashed. This is normal. I mean, I don't know this particular board, but many boards do that. Some will turn on and start glowing LEDs from standby voltage, like we had the last one. Some will just flash. Now the on switch should be this. There you go. Okay, we are on, and our LEDs are lighting up. But what's interesting is that both CPU and RAM are lighting up. So that, I did not expect that. That might be an issue. So let's get the mighty multimeter and check some voltages, because that might be significant. That might be the reason why the board is here. So first, let's check the battery. See, I didn't check for shorts before connecting, but I trust this power supply. I fixed it myself, and I've been testing it ever since, and it reacts pretty well when there are shorts. It will just turn off. So, oh, look at that, 3.063 on the battery. That is a new battery, pretty much. That is very unusual. So looks like someone was doing some kind of troubleshooting on this one as they replaced the battery. It's always a good thing to do first. Make sure the battery is okay, because some boards will have an issue with that. So let's flip it on again and check some. So right now the memory voltage will not be there. Actually, yeah, we don't need to check standby, but let's do it anyways. Yeah, we got 3.43. That's a little high, but should be okay. So this is our standby. This is created from our standby linear regulator, 3.3 volts. So at this point there's not much else we can check voltage wise. So let's disconnect it. Let's try to boot it actually, just to discharge it. And let's check the voltage drop on the why am I not getting anything here? That's weird. So these two transistors here, they give us the USB and memory voltage, or USB and dual in turn supplies memory voltage. There. So you see, this is a little low. The memory is not connected. This should not be this low. $62 ohms. That seems low to me. I think the problem with this board will be with memory. That is my hunch. Which is not too bad, because we should be able to find the fault relatively easily. Well, maybe not relatively easily, but it's definitely easier than, I don't know, faulty SIO. This is CPU. Okay, so now Vcore is connected. So now the CPU should turn off, meaning the CPU LED fault LED should not light up. The memory should still light up. Obviously, because we didn't put the memory in. Yep. It turned on and off. Yep. But what was flashing here? Yeah, CPU also flashed. So we definitely have an issue on Vcore. As I stated before, it's almost always Vcore. That's why I first connected without the Vcore, and as you can see, it works fine without Vcore. As soon as Vcore is connected, it turns off. It turns on and off. But this doesn't seem to be it doesn't seem to be the short. It sounds more like the feedback circuit is cutting out. The SIO detects the abnormality on the Vcore. That's why it turns off. So let's get rid of this. And let's give it a diagnosis. So first let's probe around a little bit. So first, let's check the Vcore for shorts. I don't think it's shorted because it would behave differently. It would shut down immediately, and it starts. It lights up the LED, and then it turns off. So that is most likely the feedback that is turning off. Okay, we have nothing on Vcore. No resistance on Vcore. That is not normal. That is not exactly normal. I would expect something. So let's grab a schematic and let's see. Okay, so our drains on all these, actually on these drains on all these transistors are all supplied from 12 volts over here. So that's why okay. Yeah, these are all connected. This is connected here. Okay, well, we need to disassemble the board, get to the transistors. I would inject some voltage here, but if the resistance shows as 0, it will likely not draw any current. But first, let's disassemble it. This is what we have here. Again, some missing capacitor over here that does not look like factory missing. It looks like someone else missing. I don't think this is liquid damage, but on the other hand, it doesn't look like something that should be here. So let's check. Okay, I don't see anything obvious here. Nothing obvious. So let's inject 5 volts and see what happens. Yeah, nothing happens. So let's inject 12 volts and see what happens then. But most likely nothing will. We need to find... No, but these are... Huh. Okay, let's analyze the schematic then. Okay, we have nothing. No power being consumed. So this most likely is not an issue of short, but we do know that it's an issue of Vcore, or at least this voltage here. Okay, I have no idea. Nothing seems to be obviously wrong here. It's not a short. It's gotta be the feedback. But I don't see the feedback. So let's try this. I don't know if that's gonna tell us anything, but let's try anyways. Let's connect it again, but this time without a CPU present. And let's see what's gonna happen. I do have another idea though. We'll see, because it might be my fault that it's not running right now. Yeah, it won't start without the CPU. That's normal. But now let's try this, because you know what I just thought? It might be shutting down because there's no CPU fan. I haven't seen that before. Normally it will just, go to the BIOS, and BIOS will tell you that the CPU fan is not present or faulty, and it just won't boot further. It will just be stuck in BIOS. That is what I would expect. But since I don't know, let's eliminate that. But I don't think the board would be on my bench if that was the issue, you know? Because obviously that's how you tested it. Unless you had the same expectation as I have, is that it will boot without the fan. But let's see. It flashed now. So without the CPU it doesn't even flash. And it won't turn on. Yeah, the same thing. And the CPU and SRAM is lighting up as well, even with the CPU. But there's no feedback. I don't see any feedback that would potentially cause it. Right? From Vcore, you would expect some resistor or something going to... Oh, hang on. Okay. How did I miss that? Vcore sense. How the heck did I miss that? Okay, so that's our Vcore sense. So now that we know where our feedback is, and we know it's there, then that's definitely our issue here. The voltage created by Vcore is not adequate, thus it turns off the board because it starts without the... And also it doesn't detect the CPU, which is explained by this. Because the CPU is not turning on, because the CPU is not getting correct voltage. So now let's see if we can spot what the voltage is, which will be hard. So multimeter is not fast enough to tell us. We need to use the oscilloscope. But it's not going to be easy at all. And mainly because we have radial capacitors here. If they were rectangular, we could attach to them from this side. And these are through holes, so we need to attach to on the other side, on the back of the board, which means most likely I'll have to solder in the wire and observe on the scope which voltage is not right. It could be either abnormal voltage fluctuations or just plainly missing voltage. But missing voltage would likely be explained by one of the transistors shorted. And actually let's check the, because I didn't check the bottom transistors, the low side. Did I? No, I didn't. So let's get, actually let's use the beeper, because if it's shorted it'll beep. Wrong side. Okay, so I'm that lucky. The first transistor I checked and it has issues. Yeah, okay. Now we're getting somewhere. We have a short over here. Let's check. This is VCCIO. This guy. VCCSA. So I was probing, yeah, I'm probing here, and I have a short. You should not have a short here. The short should be here. That's correct. That was my first measurement, but here on the face, this should not be shorted, and it is. Well, it's actually not that short, actually. Let's see the resistance of it. 8.8 ohms. And probably without the CPU, we'll have different reading. That is... Could our CPU be faulty? It could. It could be faulty, which would explain the board, shutting down when the CPU is present. 3 ohms on Vcore is normal for this CPU. Yeah, this is normal when the CPU is connected. And that's a dead end, I would think. One thing that we can attempt is to see if we can spot a heat spot when the board is trying to turn on. But I don't think we'll be able to, because it's gonna be just a quick flash. Okay, I see something. Okay, I see something. Let me hit the record so I can show you guys. But looks like we have a faulty and we got, do I have, yeah, so 1, 2, 3. Now the reason I do that is so I can synchronize the footage. And take a look here. See if you can spot it. Did you see it? I'm gonna aim right at it now. See that? Oh, that's not a transistor. That is not a transistor. That is this guy. Why do they use such heavy machinery to mow the lawn? Can someone explain that to me? It's ridiculous. Absolutely ridiculous. Yeah. So this is our guy. Somewhere here, yeah. So let's see what it is. But it might be not relevant. Let's actually, other than that one, let's keep going. Because maybe something else is gonna flash here. I was hoping one of the transistors would be heating up, like here. There is something here. What is that? Yeah, here. What is that? Oh, that seems to be a resistor. Yeah, it's definitely something's heating up here more than the others. That VCC IO, or was it IO? Yeah, I think it was IO, or GT, well, whichever. But something here. Something is not right here. Okay, let's inspect on the schematic again, or the board view. This resistor is what I think is heating up, because it's none of these transistors here. And this is high gate. Oh, high gate on this. Oh, right, because this is our control chip. Okay, this might be the one that is going faulty. And this is our gate. which is not marked, but that's definitely our gate. This is 12 volts, and this produces our phase. So this resistor will heat up if but it's gate transistor. It's usually not transmitting a lot of power. I mean, never. This is field effect transistor. It's controlled by voltage alone. The gate drain is like microamps. So the only let's try this. Perhaps it's just the gate that is, because I usually check the drain and source, right? The gate is fine, or at least the gate doesn't seem to be faulty. This resistor is not present on the board, so that's another culprit. But this is heating up. It should not be heating up. What's the resistance of it? Let's get it under the scope. The resistance should be 2.2 ohms. Yeah. That is our resistance indeed. Coincidentally, this is the rail that has the lowest resistance. Now let's check that other chip that is heating up. This could be normal. This could be absolutely normal, but it's a big chip over here. It's a big chip which is non-existent on this board view. Supposedly this is the same revision, but it's not the first time I'm seeing the differences. That is too bad. This is some kind of converter, but it's not this one. Yeah, the layout over here is different, and also, as you can see, we don't have the LEDs over here. There should be LEDs here because they are on the board. So we have minor differences in this layout. And revision is 1.01, which is this one, revision 1.01, and it's different. So that's gonna make it difficult. See if we can see anything on this chip. Okay, so we have a whole bunch of cups over here that we can test. And by test I mean we can probe. So let's try that, because I don't have a better idea at the moment. and this might be a dead end, you know, like completely wrong direction that we're going here, because it might be normal that it's heating up. It might be completely normal and the problem is somewhere else. Could be. I need something to turn on the board. So let's do this. Let's probe over here. Oh, let's turn it on first. Yeah, it went to 1 volt, which is correct. So this is, I would say it's fine. Let's start probing here. Oh, we had nothing here, but I'm measuring on the wrong side of the coil, which should be fine still. It should still show you the voltage. So let's see, where can we measure that? So this seems to be turning on, but when I measure here, I get 0. So let's see if we can find some spot over here to hook onto. On the last coil over here. Okay, this component is missing, but that's what we'll use to hook onto it. This one over here. And let's see. Well, it tried to do something. It does seem like it does start, but I don't see 1 volt on it, and I do see 1 volt on the I/O. So could be that Vcore is our issue here. It's just never went up to the proper voltage. And that could result from dry cups. But this board is modern enough, new enough, and the kind of capacitors that you use on these are not, you know, they don't go bad. They don't go bad this quickly. I wouldn't expect these to be dry unless they were faulty to begin with, which is also very unlikely. But to test that, we need to hook onto the capacitors. Okay, so the scope says nothing. So scope is set to trigger when the voltage rises. Right, so any rise, any peak would be registered, and we get nothing. So let me confirm actually. So we would see roughly 1 volt here. I just want to confirm that the trigger works correctly. Oh, okay. I messed up something. Triggered. Okay. Now we're good. And now let's try again. So this is what we see on the scope. Right. Can even grab it a little like so. See that ripple? That is not what we would expect. It is going to, let's see, horizontal, no, vertical. So this is our 0. So it goes to 1.2, even higher, 1.4 volts. It kind of stabilizes. Let's try even more. Let's see a little longer period. It's very choppy, is my point. So let's test the capacitance and the SR of these caps. What do we have here? But let's check the actual capacitance on the output here, because without the good capacitance, the power supply cannot do its job. Okay, we're over limit. There's a chance there's just no capacitance on these. Like 0. This meter can go all the way to about 4,000 microfarads, 4 millifarads. And there's no way this is more than 4,000 mics on the output here. Okay, fellas, if you know what is the capacitance of this, alright, this is likely 2.5 volts, and 821 would be the marking of the capacitance, right? Just like this one is for 16 volts, 27, and that's a multiplier, probably. But that would mean that this is like 82 nanofarads or 8.2 nanofarads. Something like that. And we know that can't be the case. Well, let's just cheat a little bit and get this guy. If we can find proper orientation. The negative is on the right. Let's trim this. So if this is a capacitance issue, which it could be, if we put the cap over here, it should behave differently, right? At least that's the theory. Capacitance, output capacitance of power converters is extremely crucial to the proper functioning power converter, right? And since I can't find any shorts or anything obvious that would prevent the rail from working, all we can see is just very choppy voltage, very choppy output voltage, which would be explained by low capacitance on the output, or perhaps high ESR. And that could also explain the behavior. So, alright, so now we need to connect everything again. Same thing, and it's also very choppy. It looks the same to me, and it stabilizes at like 145. So yeah, it was a long shot anyways. So this is Vcore. So let's check the last one that is responsible, or the last one that is here, are these GT. But as far as I know, GT is not necessarily on when you turn on the board. That I know from the laptop, so this might be different. So I might be wrong about this, which I probably am. Wouldn't be the first. But let's do the same here. Let's get the scope of this coil and connect it to this one. One last time, well, first time on the GT. Yeah, there's nothing on GT, but that's normal. Yeah. In my view, that is normal. And is there a feedback from GT? Because we have feedback from Vcore. I don't see any. We have resistor here, to ground. This is ballast. This is capacitor. Yeah. There's no feedback on GT. So the only feedback we have is on this 1K resistor. So the one last thing that we can check, and for that we don't really need the board to be powered on. So we want to check whether this resistor is proper 1K. Short over here would explain, like this cap being shorted could explain this. So let's check that. And that is pretty much the last thing we can do, because it does turn on. It is a little choppy, but I'm pretty sure not choppy enough, especially with added capacitance. It's pretty much the same. So I wouldn't expect it to be the reason why it's not turning on or why it's shutting down. It's definitely not shorted cap because oh, okay, right. Now we can just inject the voltage, right? Let's inject Vcore at 1 volt and measure over here. But before we do that, let's confirm that our resistor is 1K. The capacitor is not installed here. Am I showing you the right thing? Yeah. So this is our resistor. This one is something else. I think this one's going to ground. $500 ohms on this one. Oh, and it should be 1K resistor. But it's because we're measuring in circuit. So this should be 1K and it's showing half of that. But since we're measuring in circuit, this can be fine. But it goes to ground, right? Now this one should be 1K and it's also showing 500 even. But again, we're working with the board view that is not exactly the same. So let's inject 1 volt to Vcore and see what's gonna explode. Well, nothing's gonna explode, but we don't need a scope for this. Let's reconnect to Vcore. So we want to see some voltage over here. 264 264 millivolts. Because our voltage dropped to 770 millivolts, because we're limited to 1 amp. Let's drop the voltage to 800 millivolts and increase the current to 2 amps. And now we are grabbing 800 millivolts, but also at only 1 amp, basically. Yeah. So this is our limit now. 1 amp. So this is definitely not anything unusual. 280. 280. Shouldn't it be half of the voltage? We are going up to 1.4, around 1.4 volts when the board starts and starts producing Vcore. But let's do 1, and we're grabbing 1.6 amp. So this should be, yeah, this should be 500 millivolts, and we are having here 300. because something's not right here. It's definitely a feedback issue, because the board turns on and turns off. There's not much more that can cause such behavior other than feedback. Well, the feedback, the feedback will cut off when the voltage is incorrect. But if the feedback circuit itself is faulty, that would give you the same result, the equivalent of voltage being wrong. Okay, we're grabbing only 1.6 watts, so I don't expect anything to be crazy hot. As I said, normally when the board looks like this, right, the CPU socket is okay, but it doesn't work. It's usually the SIO issues. And in this case, yeah, the CPU is slightly warmed up, because that's what grabbed all the power. That's why I couldn't see anything on the thermal camera. But it's usually SIO, and in this case, it could be that the SIO is faulty and it just doesn't, I don't know. I'm not sure. It's a weird scenario. But only, so if this was faulty, oh, why is this coil, oh, now it's hot because I just soldered onto it. That explains why it's hot. And this should be only 1 volt. But the voltage was nice, 1 volt on this one. Without the scope, but we can connect the scope in a second to make sure. Alright, let's inject. Yeah, we have almost no power coming, almost no power going anywhere. 0.5 watt, so nothing's gonna heat up here. So this is where we get our VCC IO, and with these 2 resistors, okay, it goes to two different pins. SIO, VCC-IO SIO, and VCC-SA SIO. I'm not sure if that's a feedback or it actually uses this voltage for something. But the SIO is definitely supplied by standby voltage. Let's see. So turn it on, and we should have some voltage here. Oh, and here we have 694. Alright. Oh, shouldn't this cap also have it? It should. Over here, yeah, 693 on 1 volt. Alright. 875 comes here. 875, 694. So this does not make sense. This resistor over here, this guy over here, on this side, here. This should be our VCC IO, 1 volt. And we have 875. So that is not what we expect. 875 here, even though we're pushing 1 volt. Let's see, without the load, is it the load that causes the drop? Because our connection on the other side is not perfect. So, you know, yeah, now it's not grabbing any power. So this should be 1 volt here now. Yeah, 996. So this one should now have 996. Yeah. I don't know. I do not know. Normally when you connect Vcore and it shuts down, there's some indication of what is faulty on Vcore, right? You see a shorted transistor, you see maybe shorted cap, the voltage is low, right? Anything. And here I don't see anything. The voltage goes correctly. I mean, it takes a little while to rise, and maybe that's the issue. Maybe it takes too long to rise, but in that case I would expect it to go up and just drop. And we see on the scope it goes up to the level and it levels on for as long as I can see. Injecting stable voltage also does nothing. So I think at this point I'm gonna call it the faulty SIO. It's just because I don't have a better idea. I might go through the board view again and perhaps find a reference voltage, because if our reference voltage is low or high or something, then, you know, even though the voltage provided to the feedback is correct, if the reference is off, it will behave this way. So that's something to do, but it's a tricky one, and I think we're gonna fail on this one. Now the failure is mine, no worries. If you guys have any ideas what can be causing this, drop it in the comment. I would love to fix this one, but I'll just keep it for parts, I guess. Well, sometimes it just is what it is. Alrighty fellas, I hope you found some use out of this video. Thank you very much for watching, and I shall see you in the next one.